Thank you all for joining us for today's Azure Architecture Series webcast, Windows Azure Architecting for Cost, presented by David Pallman. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by David Pallman, Neudesic's General Manager of the Custom Application Development Practice. We are very excited to have him present for us this morning. If you are logged on, you should all be able to see the title slide that states Neudesic. There was a brief intro earlier regarding features within my meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the seating chart feature within my meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when the link is available. If everyone is ready, please make sure your seat color is green. At this time, I'd like to turn our presentation over to David.
Thank you, Amy, and hello, everybody. Glad to be with you. Today we're going to be talking about Windows Azure architecture from a cost perspective. This is the final segment of an 8-month series we've been doing on Windows Azure architecture. In the past, we've talked about compute, storage, additional data, communication, security, networking, and overall application architecture. And now I want to talk about a very important consideration, cost. So our agenda is we'll talk about the cost dynamics in the cloud and how they're different from in the enterprise, what the Windows Azure services in particular cost and how they're metered, how you can model your cost, tips for architecting for cost, incorporating cost considerations into your design, and then how to manage cost operationally. So the dynamics of cost, the way I like to think about the cost in the cloud versus on-premise is the house model versus the apartment model. So if you think of the enterprise being a house model, you typically think of the servers and hardware you need to support your web solutions as capital expenditures. Typically, you have a big upfront cost that you have to do some prediction on and size and make those purchases, get budgetary approval. Kind of harder these days in these lean economic times. And in the cloud, there really are no upfront costs hardware-wise. It's just pay as you go. So it's really an own versus rent type of thing. In the enterprise, you buy the stuff and it's yours until you sell it or it's dead, or you decommission it. In the cloud, it's yours as long as you want it, but you can release it anytime you want to. As far as where you put things and maintenance and upkeep, things you buy, servers, that's your responsibility. In the cloud, that maintenance and even things like patching can be handled for you. And then scale is interesting too, because it's sort of one-dimensional in the enterprise. You either scale or you don't, but you typically scale up. And in the cloud, you might scale up as well as down, depending on changing conditions. So here's a slide that if you've been in the Windows Azure space for any point in time, you've probably seen before, but I think these two are still tell a pretty good story, illustrating how cost is so different in the cloud from the enterprise. In the enterprise on-premise, we tend to have kind of the step function here. We buy the vertical part of the staircase line here is that we're buying some hardware. This green wavy line is a hypothetical load of an application over time. So the vertical part of the staircase is we're buying some hardware, and then the horizontal part as time goes by, and we're happy with that. And then we buy more. Why do we buy more? Either because we're seeing load increase, or we just fear that it might. We also want to be on the safe side and have more than we need. What happens, though, is we tend to either be overprepared or underprepared. So we have this, if we're on the safe side, which is good from taking care of our user standpoint, we have spent more money than we need to, or we spent it sooner than we need to, and it's a waste of capacities. Even worse is if we get it wrong the other way, and there's a sudden surge, and a lot of these conventional procurement processes, I hear everything from 6 weeks to 6 months to get new hardware. We can really be unprepared for sudden surge in load and not be able to handle that, and then we have an outage, and nobody wants that. So this is pretty inefficient. It's totally what we're used to, but that doesn't make it good. So let's contrast that to the situation we have in the cloud. Same hypothetical green line here of changing load over time. What we do in the cloud is we simply watch what's going on and dial the cloud to match as closely as we can. And anybody can see that this is way more efficient. It does come with a responsibility to watch what's going on and tune your deployment size. But that being said, it's this more than anything else is where great cost savings come in the cloud. So in this consumption-based world, where computing is becoming a lot like home services you're used to, like electricity and water and fuel and such, you only pay for what you use and only use what you need. And that sounds pretty good, and it is good. But it's important to understand there's an upside and a downside to that. The upside is it's pretty fair. It's a pretty fair way to go. We like this model generally, and it really can lead to significantly reduced costs. We've had some customers who've reduced their IT costs by 90% using the cloud. On the downside, though, the cost is variable month to month, and for those who really like locked down, projected fixed costs, everything costing the same month after month, you're not going to have that with the cloud. You're going to have variable costs. It does ultimately work to your benefit, but you have to come to grips with that. And there is a responsibility that because you're in a consumption-based model, you have to manage your consumption, and that both means incorporating it, factoring into your design, as well as managing it operationally. So what do services cost? Let's talk specifically about the Windows Azure platform now. What do services cost? Well, the answer is it depends. It depends on which services you're using. And each of the services in Windows Azure have one or more charging meters. 1 to 3 is typical. And since it doesn't sound too bad, but since most of your solutions are going to use multiple services, for example, hosting and storage, you're going to you have quite a bit to make sure you're taking everything into account here. In addition, bandwidth charges apply across the board to nearly all the services, and that may be something you're not used to calculating or considering. So let's get into the service by service here. So the compute service, which does your hosting, has 5 different VM sizes, and there's a really low-cost, extra small VM size. It's only used to be 5 cents an hour. Microsoft reduced it recently to 4. And then we have kind of the big 4, small, medium, large, and extra large, where you get 1, 2, 4, or 8 cores, increasing amounts of memory and local storage. And that's a multiplier of 12 cents an hour. However, this is all multiplied by the number of server instances you have, and generally it's recommended that you have at least 2 instances of a VM for each role of your solutions for high availability. Otherwise, the SLA isn't committed to by Microsoft. And of course, you have these bandwidth charges going on. And in case of bandwidth, Microsoft used to charge 10 cents a gigabyte in and 15 cents out. They earlier this year decided they weren't going to charge anything for ingress, so now it's only an outgoing charge, but it is still there. Then we have the storage service, and here you get charged based on the amount of data you're storing, 15 cents a gigabyte per month, a very reasonable charge. There's also a transaction fee. What a transaction means here, a storage transaction is I'm putting something in storage, or retrieving something from storage. Doesn't matter what the size of that is, but there's a 1 cent per 10,000 transactions fee. Or even checking storage, like checking if there's anything in a queue, there's a transaction. So it's a tiny charge, but it can add up if you are responsible about how you access storage. And again, bandwidth is in there too. Something you might use with compute or the storage service is the content delivery network. This is a worldwide network of about 24 edge cache servers that will you can send access to your blobs of storage, or dynamic content from your hosted service can flow through this CDN and be served up. The cache will be served up to different locales performantly. The charges there, again, bandwidth. It's the same cost structure as bandwidth is, but it's for the edge servers. And there is a transaction fee, 15 cents per 10,000. In addition, the very first time somebody goes to one of these CDN nodes, if it doesn't have the content needed, it has to go out and get it from the storage service, and those charges apply for its bandwidth and its transaction fee. Cache service, which was released this year, gives you 6 different sizes of cache, 128 megabytes up to 4 gigabytes, and charges ranging from $45 to $325 per month. We don't have bandwidth listed here because you typically consume this from within the cloud, and bandwidth charges only apply when you're crossing in or out of the data center. SQL Azure Database Service. You're charged here on database size. There are 7 sizes from 1 gig up to 50. Just rounding it up a little bit, it's basically $10 a gigabyte per month. So 1 gigabyte is $10 a month, 50 gigabyte is $500 a month. And of course, bandwidth applies. Now, does bandwidth apply? Well, it depends. If you're consuming this from within the cloud, no. But if you're consuming this from outside the cloud, yes. Service Bus, part of the App Fabric set of services. You get charged based on connection. It's $3.99 for one connection, and you can buy packs from 5 up to 500 to reduce that cost a bit. The Access Control Service for different types of authentication. It's only $2 for 100,000 transactions, extremely reasonably priced, plus bandwidth. So I've been talking about bandwidth as accompanying almost all of these services. So what's exactly going on there? Well, there's all sorts of different types of solution architectures that you might have, and there's all sorts of reasons why you might have some of that in the cloud and some of it not in the cloud. Almost no solutions are entirely in the cloud, unless it's a solution that doesn't communicate with the outside world, which is unlikely. So if you have users accessing a website of yours in the cloud, if you have client programs accessing web services in the cloud, somewhere they're going to cross over in and out of that data center. It's inevitable. And different ways you can split that. So, for example, it's becoming more trendy to have more things on the web client side. If you use solutions like, say, Silverlight, some of your code is executing in the user's computer. But still, one way or another, between presentation, business web services, and data tiers, you're going to be crossing into that data center if it's in the cloud. And what you need to do in your architectural diagrams, as you look at your solution, is figure out where this line is, the bandwidth toll line. Wherever that boundary is between cloud and non-cloud is where bandwidth charges apply. They do not apply elsewhere. In this diagram, we have the user's browser accessing a website, and we have bandwidth charges. What we don't pay bandwidth charges for are the web role and worker role talking to each other, accessing storage or database, the web role invoking web services on the work. None of that costs in terms of bandwidth. But that outside access from a user's browser to the hosted website, that does. So we're not going to go into a lot of detail now on calculators things, but I just wanted to mention in passing some different tools out there. I think we in Neudesic had the very first Azure RI calculator, but of course Microsoft has one too, and they recently upgraded this earlier this year to a really nice online calculator at Azure.com. So I do recommend using it. It's got nice sliders and things, and actually let me just give you I'll give you a preview in a minute. And then, because our original one is still up there at Azure RY, thecloudapp.net. We also have another tool which we think is kind of unique, and called the Azure Cost Modeler, available for you at AzureCostModeler.com. And where this comes in handy is that you can model the fact that you might have different levels of resource need in the cloud over time. For example, a seasonal business, or just modeling known patterns of behavior that isn't necessarily a one-size-fits-all thing when it comes to predicting cloud costs. So let me just give you a quick preview of a couple of these here. So the one is Azure.com site. This is the pricing calculator that's been redone, and again, you can see it's very very pleasant to use and simple. So you choose a compute instance, database size, and such, and you're good to go. The Windows Azure Cost Modeler is here. The idea here is that you can set up one or more of these profiles that you can name, and you can set your usage parameters there, and then you can add this to your timeline, so you can model different times a year. I'm going to set AzureCostModeler.com. So let's talk now about architecting for costs. What do you do in the design and development of your application to support costs? Well, you've got to start with some critical questions. You need these considerations to be front of mind. First off, am I factoring costs into my trade-off decisions? And of course, to do that, you need to be acquainted with the things we just talked about. Another one that people often miss is they think about cost only in terms of the production costs of what Microsoft's going to charge you. Well, there are two other aspects of costs. First is development cost. some of your architectural decisions may impact your development period, and what something you might do to save on production costs might cost you more in development costs. You really need to look at this other side of it. And there's going to be an operations cost because all the goodies of cloud come with the responsibility for management. So what is the operations cost going to be? Are you thinking of that in your solutions? So you really want to look at all three: development costs, production costs, and operations costs. Now, if you're migrating your existing app to the cloud, you might be doing that because you already have the app and say, well, of course I'm going to migrate, I'm not going to rewrite my app. But you actually might want to think about that carefully. Migrating existing app might not be cost effective in the cloud because there are some very innocent on-premise behaviors that aren't necessarily a good idea in the cloud that can cost you money. And sometimes redesigning for the cloud is going to be a lot more cost effective. I'm not saying always, but I'm saying you should look at it. So then you want to ask yourself, are you avoiding costly behaviors? We're going to go into some of those in a moment. You also want to ask yourself, am I in an elastic scale scenario? You might have an app out there that you're going to put in the cloud, and it's got a stable population of users, and it's not going to change. That's fine. Cloud is still probably a good idea for you. But if you're in an elastic scale scenario where load fluctuates, first of all, that's what makes the cloud really pay off strongly. But if you're in that situation, what do you need to do to support it? So first off, I want to let you know that sometimes you don't have to do anything to support it. There is a threshold below which you don't have to worry too much. So in the compute service where you host services, you really need a minimum of 2 servers, of the small size at least, to have high availability. And maybe your needs are less than that. Maybe you only need 1 server. Well, you're still going to want those 2 because you need that high availability. So if your load is fluctuating but it's below that level, it's not going to really matter very much because that's sort of a minimum footprint for anything serious in the cloud. But if you've got something larger going on where you need 2+ servers, you need 3 servers at times, or 5 or 10 or 100, then you are in an elastic scale scenario. There you really do want to pay attention to scaling up as well as down. Otherwise you're going to be in trouble either in terms of cost or in terms of being able to support your users properly. So you've got to think about, in that case, what is the mechanism you're going to use for scale and cost management. It's not automatic, so you've got to put something in place to handle that. And that could be automated, that could be done through people in process, but one way or another needs to be addressed. And then, so you're not blind. You need some feedback once you've deployed to know what to do about scale. And one piece of feedback is your monthly bill in terms of cost, but you really almost certainly want to instrument your app to capture the things you need to let you make good decisions about what your app is doing. And ideally, you want to build in some knobs to your application, some settings, so that you can tune its behavior. So let's talk about some trade-offs. In terms of the compute service, as you go with a larger VM size, that's going to give you more cores, more memory, more local storage. You're also going to be looking at a higher hourly rate. In fact, from small up to extra large, each successive size doubles the rate. The more instances you run, and you do want to run at least 2 for high availability, but the more instances you run, the higher your charge is going to be, obviously. Some costly behaviors of compute. Well, if your app is running on more instances than you need it to, that's unnecessary charges. If the app is idle, nobody's using it, but you have it deployed, well, the way that compute hours work is it has nothing to do with usage. It's as long as your app is deployed chronologically on wall clock time, hour after hour, you are paying. Or an app that's no one's even using anymore, no longer needed, but you've forgotten, you just left it there in the cloud. Well, that's going to cost you month after month. Some tips and tricks around lowering costs with compute. Sometimes you're tempted to take an app away altogether because it's not really being used very much. Sometimes it's true of things like HR health plan renewals that only happen twice a year for the most part. So sometimes you don't want to totally remove a website because somebody might need it, or you even want to be tipped off that somebody's starting to use an app again. But you don't really want to pay a lot because it's not going to be generally used. Well, an alternative is to use the extra small instance and put your app in sort of a caretaker mode rather than shutting it down completely. And if you start to see usage, you can deploy it to a larger VM size and a larger number of instances. Now, if you've got websites to host and they happen to be static or content only, if they don't have any kind of server-side logic or storage needs, it's actually possible to host those out of blob storage rather than in the compute service. If you look at the compute service, a small instance, minimum of two instances for high availability, it's $187 a month plus charges for bandwidth and storage. Blob storage, a couple dollars a month. So it's compelling for that use case where your website is static. And then on the roles that you do host in a compute service, you may want to take your website and your web services and share them in the same web role. Now sometimes you don't want to do that. You don't want to do that if they have completely different VM needs or they're not compatible. But I'm thinking here, for example, a typical ASP.NET website and a typical WCF web service. Those combine very easily in the same solution in Visual Studio, and they can deploy to the same role. However, don't do this if in a large-scale system. If you want to preserve the ability to scale your website and your web services separately, or if they have wildly different authentication models, those might be reasons to use separate roles. Data. So some data trade-offs. Well, in the enterprise, the database is king. But in the cloud, relational database is still important. We have the SQL Azure database, which is similar to SQL Server. But there is kind of a different ratio. Perimeter storage is used pretty strongly in the cloud, too. And that's part of the influence of the way we do things in the cloud, which is very lightweight and distributed. That's partly the influence of things like the devices, and it's partly the influence of the NoSQL movement. So you can expect to use relational data in the cloud, but you should also expect that primitive data is going to play a large role. And you should really think through data artifact by data artifact, which is the best choice for you. However, even though primitive storage is quite a bit cheaper than relational storage, there's going to be an impact on your development team. They might have a big learning curve. It might slow them down. So that development cost thing will have to be considered there. And then if you just like keeping your data around for a long time for easy access, that's great. But you are going to pay for that. The more data you keep in the cloud, the longer you keep it there, the more you're going to pay. So some tips and tricks around data and cost. Well, again, consider using that primitive storage, but just it's 50 cents a gigabyte versus $10 gigabyte per month. But I have found that for some development teams that's great. They gravitate towards primitive storage, but I've seen other development teams really never regain their productivity in adjusting to it. So you want to really think about that carefully. Also, keep in mind you don't have to handle all your data in the same way. It's fine to have a split between SQL Azure database storage and some blob storage, some table storage. If you've got a really large amount of data, we currently have a SQL Azure database limit of 50 gigabytes. If you've got a real large amount of data, you're probably going to be partitioning your data. Or if you use primitive storage, like when it's Azure table storage, you're going to be using partitioning also for large tables. There's lots of ways to partition, different natural and unnatural ways you can partition your data. But the one I really like is partition based on date range. And the reason that that's so good is it gives you an automatic sliding window. As time goes by, you'll be creating new partitions for that month or quarter or whatever granularity you're tracking, and you automatically have these oldest partitions ready for archiving and deletion. There's something you don't have to do any kind of rocket science to figure out what to remove. It's right there in a partition for you. Also, you want to not all the storage necessarily has to be in the cloud. You might want to leverage client-side storage, as we have more sophisticated computers and devices these days. So native device apps have device storage they can use. HTML5 apps and HTML5 capable browsers can use local storage, as well as things like cookies. So not everything necessarily has to be in the cloud. Some costly behaviors, poor master data management. So when you put your data in the cloud, does that database in the cloud become the master system of record for your data, or is it just sort of a projection from a master that's still on site? You got to think about that, because that's going to require syncing, and that could be very expensive. That could even be the most expensive part of your operation, syncing, if it's unrealistic, too ambitious. And if you've got unnecessary data in the cloud, those are unnecessary charges. Obsolete, old data in the cloud you haven't removed, unnecessary charges, month after month. If you're storing things in a very inefficient data format, maybe that didn't matter on premise, it does matter in the cloud. And not to put too fine a point on it, but even like in things like blob storage, the total size that you're measured on for charges, it even includes like the length of your file names. So little things do matter. If you have a lot of anything, little things matter. There's a multiplier effect. And then behaviors like polling on storage, like looping on a queue. Not going to kill the enterprise, but not a good idea in the cloud. You have that ongoing transaction charge you're racking up. Communication. Well, unnecessary communication is going to cost you in terms of bandwidth. So is redundant communication, inefficient communication, or overly chatty interfaces. All of these will contribute to higher bandwidth charges than you need to have. So some tips and tricks around communication and bandwidth. Just think about being efficient in communication. Take your website, web service request responses, and compact them as much as you can. Streamline them. If you're serving up content like images and video, or are they right-sized? And discard what you don't need, and minify what you're going to keep in that communication over the internet. Then, if you fall into a situation, you really have to program for retries when you're consuming cloud services over the internet. And you want to use a sensible retry policy. So, not doing retries is going to kill you. However, you can overdo it. So you don't want to be thrashing. You don't want an infinite loop of retries. And really, the best way to do retries is not only to do a limited number of them, but to have a back-off timing interval where if something fails, you retry it. If that fails too, you wait a little bit longer before you retry the third time. Affinity. It's a really good practice to keep data and the code that accesses it near each other. Wherever that place is. It could be in the cloud, it could be on-premise. But when that's not the case, then you're doing all this communication over the internet that not only may hurt you in terms of performance, but it's going to cost you. And then, as PCs and devices and browsers become more and more capable, we want to take advantage of client-side caching. You don't want to make unnecessary or redundant requests to the cloud if you've already recently gotten the data locally. All you have to do is design in a way of storing that and pulling it back. So take advantage of device storage, HTML5, local storage, and cookies. Some general cost tips and tricks for your solution, especially for large solutions. Consider the CQRS program. If you're not familiar with that, the command query responsibility segregation pattern, that's a mouthful, really just means that things that can modify your data and things that are kind of just read or query oriented can be separated, implemented separately. And a couple good reasons to do that. One is you probably don't do the same amount of reading and writing. And then, there's also a very practical reason that you see in languages like the Eiffel programming language that, if you're calling something that you know is query or read-oriented, there's no chance of accidentally updating something. So in terms of Windows Azure, you might decide to implement read and write separately, not only so you can scale them to different levels, because you probably don't do the same amount of each. But you can also use very lightweight mechanisms for data reading, such as database snapshots and things like that. Then you want to think about autoscale. Now, you might not need this autoscale, but if you are, you might think of how you would implement that to remove apps and data that's deployed when you don't need it. You should have a strategy on when you're going to scale up and down. That could be based on changing load that you see. That could be based on known peak and off-peak seasons. Maybe you're a seasonal business. That could be based on known patterns of behavior. Maybe you do reservations, and on the first day of each month is your busiest day. And so you can do this autoscale sort of anticipatory or reactive. Anticipatory means you know something's going to happen. You have the system kind of scheduled to do its thing in terms of changing its deployment size. And there's a service management API. You can do all this programmatically. Or you could be reactive. You see, you're tracking your load, you're tracking your usage and behaviors, and you decide to act on that. And again, this can be automated, but it doesn't have to be. It's perfectly okay to do this with people in process. The important thing is to address it one way or another. Then optimize for cost. You want to kind of trace in your modeling of your solution. You want to trace costs across your use cases. Follow your use cases and think about the cost that's going on. You want to identify your cost bottlenecks, and really, what you can do is you can treat this like a performance problem. Many of the performance tuning techniques out there are also cost tuning techniques. Plus, you want to get out of the way. Sometimes we want to engineer too much, and it's overkill. A good example would be serving up images in your website. You could flow those images through your web server, but that's really unnecessary. You can take your images and put them in blob storage, which can be set for to be served up as public internet URLs, and then you just reference those URLs in your website's HTML, and there you go. The browser goes and pulls those things. So let's kind of summarize this in terms of what I call the 7 deadly sins of cost in cloud architecture. First, we have lust. Don't over-engineer what you do. And also, a lot of the cloud services. When I talked about cloud services earlier in cost, I didn't cover all of the services in Windows Azure because many of them are in C2P preview. And it's kind of okay to use those, but we don't know what the cost model is going to be or the rates. So from a cost standpoint, you should be a little wary of using unpriced CDP services as a solution. Second would be gluttony. Don't consume more than you need to. There's just no reason for it, especially because you can always, adjust your scale when you need to, when you feel the pain. Number 3, greed. Look to reduce your footprint, not increase it. Sometimes in enterprise we take pride on running on a big, cutting-edge, shiny new server, and we really want to load up, and but there's no value of that in the cloud. It just costs you more money. So you want to reduce your footprint as much as possible. Number 4, sloth. You really need to be proactive about managing app and data lifetime. Otherwise, you're going to be paying unnecessary costs month after month. In the enterprise, we could be lazy about leaving old apps deployed and old data around. It didn't matter, but it is going to hit your pocketbook here. Number 5, wrath. So when you're handling errors, consuming cloud services, and you're going into that necessary retry logic that you have to have, don't thrash. Don't have infinite loops. Calm down and do a backup timing interval. Number 6, envy. You don't have to be just like the enterprise. Not everything in the enterprise is good in the cloud. As we've seen already, many behaviors that are innocent in the enterprise can cost you in the cloud. It's okay to be different. And number 7, pride. You might be a seasoned professional, but the fact of the matter is to really use the cloud effectively, especially from a cost standpoint, there are some new things you need to learn and maybe some things you need to unlearn. Okay. So, what about managing costs after the fact? Well, just briefly, before your app is designed and developed and deployed, you could use these tools we showed you already to model your projected costs and design with cost in mind. But after the fact, what you need to do is you need to track your actual costs, and you need to manage your consumption and billing. So how do you do that? Well, you or your spouse already know how to do that, right? The way that you would look at your monthly bills at home is exactly what you need to do. It's a habit you need to be in. I'm getting a bill, I need to look at it. Is it expected, or is it a surprise? If it's a disturbing trend, you want to identify that as early as possible and nip it in the bud before it becomes a big financial problem. But the bill is not really enough, right? You really want to capture sufficient information about your app to be able to take action. You want to build in some controls to change behavior. So really what this comes down to is you want to plan in advance how you're going to debug for cost. That's really the way to think about it. And it's really hard to add this in after the fact. It's best approached and thought through when you're designing your app. Okay, well this actually takes us, we'll take questions in a minute. This actually takes us to the end of our 8-month series on Windows Azure architecture, and we hope you enjoyed it. Since this is the final segment, we just wanted to let you know that we at Neudesic do help people get on the cloud and tackle issues like the ones we've been looking at in this series. We offer free one-day Windows Azure Cloud Assessments, which you can read about at cloud-assessment.com. And we also offer services for training, consulting, application development, and migration. Okay, I'll take questions. I see we have one already in the hopper here. Question is, Serum and Cloud, flat fee per seat, yes. Yeah, so we've been talking here really about most of the Windows Azure platform, but Microsoft does have other things to do in the cloud, and that includes their Serum Online service. And yes, I believe that is a flat fee per user. So yes, costs for software as a service are really quite different than what I've shown you here. Basically, if you take somebody like Microsoft with their Serum Online product or their Office 365 product, service rather, or Salesforce.com, they have to deal with the same things we just showed you here that you would have to do for your own applications. However, their model to the public, the software as a service model, is typically pay one price per user. So yes, if you're consuming a software as a service offering, you don't have to worry about these things, your provider does.
Great. Thank you, David, for this great presentation. I also did have a few questions that came through. As a reminder, to ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen, type your question, and click the Ask button. One of the questions I did get was, what happens if Microsoft changes their charging model?
Okay, good question. So you design your app for what you know of of Windows Azure today, and things change. The rates change, the actual model changes. What do you do? Well, I think it's unlikely that you're going to have any kind of big change or any kind of unpleasant change. Let's look at the history. Earlier this year, Microsoft went from charging 10 cents for data center bandwidth in and 15 cents out. They went from charging to charging nothing for going in and then charge for going out. So that's obviously a big improvement. That doesn't impact you in any negative way. The other thing they made is they took the small difference from 5 cents an hour to 4. So if history is any guide, the only changes you're going to see are in your favor.
Great, thank you. One other question I did receive was, how do I prevent a denial of service attack from running up my bill?
Okay, so a DOS or DDoS, denial of service attack, isn't that going to run up your bandwidth? Yeah, potentially. Of course, that can be a problem on premise too, right? Wherever you host, that's going to concern you for all sorts of reasons. What can you do about it? Well, the data center does have some stuff in it to look for suspicious behavior and take action, but ultimately, the bottom line, Microsoft or not any other provider, cloud or otherwise, can fully protect you against denial of service. You really look at it as a partnership. There's certain protections in the data center, but you, the application developer, have a responsibility too. One of those is to use good mechanisms that would thwart the type of intrusion. For example, for your login, you might want to use those CAPTCHA logins where the user has to type in what they see in a text picture. So the usual mechanisms that help resist denial of service certainly still need to be there. The third component is you're watching things. So the data center may detect some unusual activity, and they may relocate your service or do something for you, but you can't rely on that always happening. So you have to watch too. If you instrument your app to track activity, you can look at that. If you see, if you're watching your bills as they come in. By the way, sometimes people have the idea they can only look at the bill once a month when it comes. That's actually not the case at all. In the Windows Azure billing portal, you can look at your bill in progress as often as you want, daily if you wish, or weekly is actually what I recommend. So it doesn't have to come as a down the road shock if something unusual is happening. Okay, here's one. Autoscale requires monitoring data. More data means more cost. What is the best way, cost-effective way for implementing autoscaling? Best practices. Okay, great question. So sometimes the cost of just knowing what's going on so you can take good action does in its own right cost money. So when you instrument apps to track things, for example, using the Windows Azure Diagnostic System, the stuff it tracks goes into blob and table storage, which you pay for. So what are the best practices there? Well, the best practices there are, first of all, only track what you need to track. You might have a verbose mode for tracking when you're debugging a problem, but generally just track what you need to track. If you're using a tool like System Center, that is a pack that knows how to talk to Windows Azure Diagnostic Storage and not only integrate the things you track. And by the way, that can be everything from performance counters to application logs and such, trace output. It can look at that stuff. It can even give it rules to act on it. And it has automatic grooming. By grooming, I mean going out to that storage and pulling down that diagnostic info on a regular basis, bleeding it so it's not racking up charges. So my best advice there is be careful. Think it through.
Great. Thank you very much, David. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I am going to click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business, yes or no? Great, thank you. The next question, please rate the presentation content, excellent, good, or poor. Thank you. And the last question, would you like us to schedule a follow-up, yes or no? Great, thank you. We will be forwarding the link to view a recording of this webcast once it becomes available. If you have any further questions about this presentation, please feel free to email David at the email address provided on the slide. Again, thank you so much everyone for joining us, and we look forward to seeing you on our next webcast. You're now free to disconnect. Thank you.